Hi, welcome back to another class of Advanced Artificial Intelligence. This is Tarik Rashid. Today's class is about naive Bayes algorithm, naive Bayes algorithm. This is part one, kind of theoretical part, and we promise you to explain a practical example on naive Bayes in the next video. This is the first part. Naive Bayes algorithm is a probabilistic classification algorithm, which is depending on Bayes theorem, which calculates the probability of a class giving a set of feature under the assumption that the feature or the features are conditionally independent given the class. So each feature conditionally independent. So here is the probability of class feature kind of equals to probability of the class multiplied by probability of the feature in that class and probability of each feature in that class. So I can go to all features. And depending on the label of the class, that's the C, for example. Now, naive Bayes is grounded in probability theory, conditional probability, joint probability disruption, and independence assumption. So here is you have feature 1, 2, 3, and the class, and then each feature, the probability of that feature in that class multiplied by the next and every other feature. So this assumption simplifies computation significantly. Now, historically developed from the work of Thomas Bayes in 17th century, roughly, formalized and extended by Pierre-Simon Laplace, became popular in machine learning in 1990s, especially for spam filtering text classification. So that's the Bayes theorem, very simple theorem, and you need to calculate the probability of each feature in the class and work out and multiply them. So that's basic simplification, and the decision will be taken when you take the maximum of this formula. So the probability of the class, probability of each feature in that class, and multiply, and you do it for each label, and then you take the highest. Gaussian naive Bayes continuous data, multinomial naive Bayes text word counts. And we have Bernoulli naive Bayes binary features. So these are the types of naive Bayes. And advantages of naive Bayes: very, very simple, very fast, very quick, requires less mathematical expressions, minimum computation. So very good, efficient for large data set. Works with high dimensional data, so a lot of features also, no problem. So you take each feature on its own. Good performance, performs surprisingly well, despite assumptions that we provide. Requires less training data, robust even with small data sets. What are the disadvantages? Strong dependence on assumption. Rarely true in real-world problems. Zero probability will give you cannot be selected. If a feature never appears in a class, then that will be zero. Solved using Laplace smoothing. Poor with correlated features. Features, they should not be very correlated. Features influencing each other reduce accuracy. Continuous data assumption. Requires distribution assumption Gaussian. So application could be used for spam filtering, sentiment analysis, document classification, medical diagnosis, Dacian system and other systems as well. So in brief, naive Bayes is a fundamental and powerful classification algorithm that combines simplicity with strong practical performance. While its assumption of feature independence is often unrealistic, it remains highly effective, particularly in high-dimensional problems such as text mining. So this more or less about naive Bayes problem. If you have any question, please send me to my website. And the next class, stay tuned for providing practical example on naive Bayes. Thank you very much and stay tuned.